Welcome back. So we talked about nuclear fission and using E equals mc squared. You can also use the equation E equals mc squared when we're looking at fusion. And remember, fusion is when two lighter elements, nuclei, fuse together to form a bigger one. Okay, and again, we find that the total mass after is less than the total mass before. So you can use E equals mc squared, where E is the energy produced, m is the mass difference, and c is the speed of light. Again, misprint there. It should be a total mass before. Take away total mass after, because before is bigger than after. Okay, so an example of a nuclear fusion energy calculation is this one. So there's two hydrogens, two isotopes of hydrogen. One's deuterium, which is that one, and one is tritium, which is that one. They're just names for isotopes of hydrogen. And they fuse together and they form helium and a neutron. So the equation is there. So deuterium plus tritium gives you helium or an alpha particle plus a neutron plus energy. Okay, so what do we do here? Well, we find what the mass would be beforehand. So it's deuterium and plus tritium. So you'd find those on a table given to you, add them together, find the total mass before. Then afterwards, we've got an alpha particle and a neutron. Again, you'd find those on a table, add them together, and find the total mass afterwards. And take one from the other, and you end up with a mass difference. And you put that mass difference into the equation, and you end up with the energy released there. So, an example, again, I've written out already, so you don't have to watch me struggle with my pen. So the equation below describes a nuclear equation. So that's our equation. State the name given to this type of reaction. Well, it's two smaller particles fusing together to form a bigger one, so it's fusion. And B, calculate the energy released in the reaction, given the information there that we've got. So before, we've got the two isotopes of hydrogen. So we add those together and find the total mass before. Afterwards, we've just got helium, so we just know that mass from our data is that one. So the mass lost is the mass before, take away the mass after. So we've got a mass difference of that. And then we just put that into the E equals mc squared equation and end up with a small amount of energy released. Okay, right, I'm going to get you guys to do some fusion examples. These are very, very similar to the fission ones. It's just the fusion rather than fission. Okay, good luck.